Hi, a car of mass 1600 kgs moves with constant power 14 kilowatts as it travels along a straight horizontal road. The car takes 25 seconds to travel between 2 points A and B on the road. Find the work done by the car's engine while the car travels from A to B. Now we need to find the work done as the car travels from A to B in 25 seconds. So what is power anyway? Power is equal to work done divided by time, and the power of the car is 14,000 watts is equal to work done divided by time, which is 25 seconds. Therefore the work done by the car in traveling from A to B is going to be 14,000 times 25, 350,000 kilojoules. 350,000 joules. First part is done. Second part, the resistance to the car's motion is constant and equal to 235 newtons. The car has acceleration at A and B of 0.5 meters per second and 0.25 meters per second respectively. Find the gain in kinetic energy by the car in moving from A to B. Okay, now here the car has an acceleration of 0.5 meters per second, over here 0.25 meters per second. Now what can we do? Let us say this is our car, the driving force and the resistive force, which is 235 newtons, and at B is the same story, 235 newtons. The car has a driving force here. What is the driving force? Now we should know that driving force is equal to power over velocity. So we can find the net force. The net force will be the driving force minus the resistive force. So, and what is the net force? It is mass times acceleration. Therefore, the driving force, which is the power, 14,000 watts, over the velocity, I don't know the velocity at A, minus the resistive force, 235 newtons, is going to give us the mass times acceleration. The mass of the car is 1600, the acceleration at A is 0.5. So therefore, 14,000 minus 235 VA is equal to 800 VA. 0.5 times 1600 is 800. And if you were to work this out in a calculator, you're going to get VA is equal to then 14,000. 800 plus 235 is 1035. Divide that and you're going to get 13.5265. So 13.53 meters per second at A. Now what is the velocity of the car at B? Again, we're going to take the driving force, which is the power over the velocity, minus the resistive force is equal to the mass times acceleration. And this times the acceleration is 0.25 times this is 400. So we have then 14,000 minus 235 VB is equal to 400 VB, the velocity at B. So it's going to be then VB is equal to 14,000 divided by 400 plus 235 is 635. 22.05. So we have then 22.05 meters per second at B. We need to find the gain in kinetic energy. It's going to be half m times VB square minus VA squared. So that's going to be half times 1600 times 22.05 squared minus 13.53 squared. So going to give us 242,513.28. Therefore the answer should be then 242,500 joules. So this is the gain in kinetic energy. Finally, we need to find the distance AB. Now, how are we going to find the distance? What we should know is that work done is also equal to the force multiplied by the distance. But here, what is work done? Work done is 350,000 joules. Let's go to the force. And what is the force? The force, we just found it to be the gain. So, no, but first of all, force times distance. But the driving force, work done by the driving force. Okay. We're going to say that work done is equal to gain in kinetic energy plus the work done by a resistive force. So the gain in kinetic energy is 242,500, okay, plus the resistance, the work done by the resistive force. What is the work done by resistive force? It is the resistance, the resistive force itself, multiplied by the distance moved from the point of application. So then 350,000 minus 242,500 is equal to resistance, which is 235 times the distance. So therefore distance AB is going to be then equal to, so 350,000 minus 242,500 and all divided by 235, 457. So AB is going to be 457 meters. Alright, and this question is taken from October 2015, A-Level Maths, HSC Mechanics 1.